Let's calculate the derivative of an example that's going to include some trig functions. For example, suppose we want to calculate the derivative of cosine of x times e to the x divided by sine of x. One way to do this would be to just approach it using your quotient rule. You say this is a quotient, something divided by something, so I can calculate its derivative by holding the bottom, sine of x, timesing it by the derivative of the top. Well, the derivative of the top is itself a product. So to calculate the derivative of that, we need to use product rule, which is hold the first, cosine of x, times by the derivative of the second. The derivative of e to the x is still e to the x, plus hold the second, derive the first. But the derivative of cosine is minus sine, so it will become minus sine of x times leaving the e to the x the same. Okay, we're doing the quotient rule. We held the bottom, we did the derivative of the top. Now we need to do minus, hold the top, cosine of x times e to the x, times the derivative of the bottom. The derivative of sine is just cosine, so it's times cosine of x. All over the bottom squared. Sine of x squared. Let's see what that gives us. Here I have a sine cosine times e to the x. Here I have a sine times sine e to the x. And here I have a cosine times cosine e to the x. I can simplify this and write sine x times cosine x e to the x minus, I'm going to pull out an e to the x term here, e to the x times sine, sine squared. And then I had a minus cosine e to the x. So pulling out the minus e to the x, I get plus cosine squared x. All over sine squared x. And of course, whenever you see the sine squared plus cosine squared, you know that that just simplifies to 1. So what you're really left with, if we pull out this e to the x, I have e to the x times sine times cosine minus 1 all over sine squared of x. Okay, that's pretty good. That's fine. That's a fine solution. What if we wanted to avoid the mess of using the quotient rule? Is there anything we could do? Well, we could have started at the very beginning by noticing that cosine divided by sine is just cotangent. Sine divided by cosine is tangent. Cosine divided by sine is cotangent. So here we actually have the derivative of cotangent of x times e to the x. And when we fold that into cotangent, we no longer have a quotient here. It's merely a product. So we can just use the product rule. We hold the first, cotangent of x. We times it by the derivative of the second. The derivative of e to the x is just e to the x. And then we want to add to that, hold the second, derive the first. So hold the e to the x times by the derivative of cotangent. What's the derivative of cotangent? Remember, the derivative of tangent is secant squared. The derivative of cotangent is minus cosecant squared of x. That's it. Now you might be worried, didn't we get different answers in these two problems? But stop and remember, cotangent is just the same thing as cosine over sine. I can factor out an e to the x from both these pieces. And my cosecant is just 1 over sine squared of x. We nearly have the same thing now. If we get a common denominator of sine squared, This first term needs another sign on bottom, so you need to multiply by sine on top as well to get sine times cosine minus this 1, and I have my e to the x out front. So they really do come out to be the same thing. Although sometimes if you begin with a slightly different form of whatever your starting equation is, you can end up with a slightly different form as well. And so you might take an extra step to pass from the one form into the other form.